Welcome to today's lesson about similar shapes, where we're going to look at some of the harder questions that we now see on the GCSE papers. Let's have a quick reminder of how similar shape problems used to work in the past. Basically, we could use magic triangles to solve the problem, because in similar shapes, they're basically an enlargement of one shape to another. And therefore, if we look at the length of a particular side in the big shape is just simply the corresponding side in the small shape times the scale factor. And that scale factor will be the same for all the sides. Then we look at area. The area of the big shape is just the area of the small shape times that scale factor squared. And for volume, the volume of the big shape will be the volume of the small shape times the scale factor cubed. And all these problems were essentially look at the information we've been given, put that into one of these magic triangles, find the scale factor. Then once we found the scale factor, you'd be asked to find something else where you would need to use the scale factor. So the problems were basically magic triangle based, find the scale factor, use the scale factor. But now we're seeing harder problems where we've actually got to look at what we know about similar shapes and use it. We've got to actually increase our understanding of what this topic is about. So what we've actually got to start doing is realizing that in similar shapes, obviously all the angles are the same. But equally, the ratios between the lengths are the same. So we look at these two triangles here. We've got the side between the blue and the green and the red, and the side between the green and the orange. And the ratio in B for these triangles is going to be 4:7. Never mind the fact that the scale factor is 2. It's this ratio that we're going to look at. And what we have to realize is that to solve these harder problems, what we do is we have to actually put the angles into the shape and then work out which are the two sides. And what we're going to end up with is some equivalent fractions. So we've changed the problem from being a magic triangle problem to an equivalent fraction problem. So let's look at this one here. So what we've got is we've got two triangles which actually fit in one another. And we've got a big triangle and a little triangle. But because the two triangles have to fit within one another, if we look at the angles here, this blue one is going to be in the big triangle. And we'll just highlight the big triangle for ourselves. The big triangle's the one round here. Ooh. And you've got the small triangle. And the way we then do it is say, okay, we're going to call this angle an orange angle, and that one's the orange angle as well. Because in a triangle, the angles have to be the same. So we've got a blue one in both triangles, an orange one, and a green one. So then if we look at the big triangle, the small triangle, and start comparing the ratio of the sides, we've got the blue to green side and the blue to the orange side. And we look at the big triangle, blue to green is x plus 10, and blue to orange is going to be 40 because we've got to add the 2 up. With the triangle, small triangle, we can just look at it and say, yep, blue to green is just 10, blue to orange is just 4. And so what we've now done is set up an equivalent triangle, equivalent fractions. We've got one unknown, and all we've got to go and do is solve it. And just quickly look at that. Let's change the pen. Right, so to get rid of the 40 on this fraction, we're going to times that by 40. But what we do to one side, we have to do to the other. So we do that. Let's see what we end up with. We end up with x plus 10 equals 400 over 4. I know 400 over 4 is 100. Then I take 10 off each side. So we got 90. To be fair, we could have used the magic triangles to do that by separating the two shapes out. But then finding the other value of x was remarkably difficult and took some time to do. But there's a very simple trick to being able to do it. So let's clear our drawings. Let's get the mouse back. Let's look at the next shape. Right, and the simple trick is, all we do is we're going to swap those two angles around. That's all we've done. So now we're going to say this angle's orange, that angle's orange. So we've got two triangles which have got exactly the same angles in them. It's just that they're in different places to where they were in the first one. And by doing this simple trick, we've then enabled ourselves to solve the problem. Because then if we look at the triangle, look at the ratio of the blue to green over blue to orange. Let's have a look at the big triangle. Big triangle's here. There we go. Nice big triangle. So again, blue to green is going to be x plus 10. But in this time, blue to orange is going to be 40 because we've got to add those two together. Then if we look at the small triangle, blue to green is just 4, blue to orange is 10. And so we look at this, we've now set up our equivalent fractions. And we'll just quickly solve this. All right. So what we're going to do is we're going to times both sides by 40. Now, if we do that, we end up with x plus 10, because we got rid of the 40 on the bottom. And on the other side, our 4 turns into 160, which is over 10. So x plus 10 is 16. So we take 10 off each side, x is 6. So our two answers were 9 and 6. And so that's how we solve the problem. So rather than looking at similar shapes just purely as a magic triangle type problem, we've actually got to start looking at similar shapes as an equivalent fraction type problem. And the way we set the equivalent fraction up is to look at the ratio of the lengths of the sides in the shape. And once we've done that, actually doing this problem is not that difficult. So thank you for listening, and I hope you'll tune in again for some more videos.